All right, in this section, we're going to be working in section 1.4. So our learning targets for today are I will be able to, and I can, at the end of this lesson, solve absolute value equations, solve equations involving two absolute values, and then identify special solutions of absolute value equations. So now, the big thing to remember is that an absolute value equation is an equation that has an absolute value expression. And an absolute value expression has those absolute value bars. This would be an absolute value expression. Okay. So here's one of our first core concepts, the properties of absolute value. So we're going to say that A and B are real numbers, just meaning that they're numbers that we recognize and can deal with. I know that the absolute value of A is greater than or equal to 0. The second property that I know is that the absolute value of a negative A is equal to the absolute value of A. So I can just take anything that's negative inside the absolute value sign, and it's the same thing as the positive value. They're interchangeable. I know that if I'm multiplying two things together inside of an absolute value, it's the same thing as taking the absolute value of one and multiplying it by the absolute value of the second one. So similar to that is dividing. If I'm dividing A divided by B and taking that absolute value, I can take the absolute value of A divided by the absolute value of B. So now I'm going to be looking at solving absolute value equations. So to solve an equation such like this one, ax plus b, the absolute value of that equals c. When c is greater than or equal to 0, I have to solve my different linear equations. So I always have to set up two equations to solve this. I set up ax plus b equals c, so I just rewrite the equation the first time without the absolute value symbols, or my ax plus b, so the thing that was inside the absolute value, equals a negative c. If my c, the thing that's on the other side of the equal sign, is less than 0, I know it has no solutions, because absolute value is always non-negative. It's always a positive number. Okay, so here's an example. We're going to solve these equations. So I have x, the absolute value is x minus 4 equals 6. So I remember from that last slide, I have to rewrite x minus 4 equals 6. So I rewrite everything just kind of as it's written, and my second equation is going to be x minus 4. I leave everything that's inside the same, equals, and then I switch the sign on the other side. So now that I have my two equations, I can go ahead and solve. And from our last several sections, I see here that I want to get x by itself, and I'm subtracting 4, so I have to do the opposite of that to undo that, so I add 4. So those can go away, so x equals 6 plus 4 is 10. That's one of my possible solutions. To get my other solution, I have to solve this other problem. So I have to add 4 to both sides again. So x equals a negative 6 plus 4. Since the signs are different, I know I'm really subtracting. And I know 6 minus 4 is 2. And the negative sign was with the bigger number, so that means my answer will be negative. So these are my two possible solutions. Okay, so x can equal 10 and x can equal negative 2. So now I can go ahead and I can graph what this looks like. So here's my number line. And if I have this, negative 10, we'll just make a simple number line here. So if I'm graphing this, my x equals 10 and my x equals a negative 2. It would go right about here. So then I see that here's the middle, right in between these two solutions of mine, the two dots that I made, the two solutions that I have. And this would be this is our 4. So I know that each of these values is 6 away from 4. Each value is 6 numbers away from 4. So that's kind of what we're looking at, just so we can double check and make sure that we're right. So now I want you to go ahead and try example B and see what you can come up with. So here's a couple of examples that you can try on your own. I want you to go ahead and solve this one right here, just for some practice. So here's another example, right? We're making this a little bit more difficult because we're adding another value on here. The first thing I always have to do is get the absolute value by itself. So I see that this absolute value is over on the left side with this negative 10. So in order to get rid of that, I have to add the 10 first. to both sides. And remember, I always have to add things, do the same thing to both sides of the equation. So now I have the absolute value of 3x plus 9 equals, those go away, negative 4 plus 10 is a positive 6. Now that the absolute value is the only thing on the left side of the equation, I can go ahead and write my two equations. So I have 3x plus 9 equals 6. And then I also have my 3x plus 9. Everything that's inside equals, and then I switch signs, negative 6. So let's solve this first one. So I see that we're adding 9, so I have to undo that by subtracting 9. So I'm left with 3x equals 6 minus 9 is a negative 3. Then I'm multiplying over here, so to undo my multiplication, I divide by 3. So x equals a negative 1. That's one of my solutions. So now let's go solve this other equation. So I want to start the same way. I have to subtract 9. So I end up with 3x equals negative 6 minus 9 is a negative 15. Again, I see that I'm multiplying, so I have to undo that by dividing. So I end up with x equals a negative 5. So these are my two possible solutions to this equation. The only difference between this one and what we were previously looking at was I had to get rid of this 10 value first, and I did that by adding it to both sides. Alright, so here's a word problem we have to think about. In a cheerleading competition, the minimum length of a routine is 4 minutes, and the maximum length of a routine is 5 minutes. Write an absolute value equation that represents the minimum and maximum length. So the first thing we have to do, right, is we have to understand the problem. So I know the minimum and I know the maximum, and then I have to write an absolute value equation. So in order to do that, I then have to make my plan. I know that these are both solutions to this absolute value equation, so I want to use a number line to find the halfway point. So I can just write my simple number line, and my minimum, I was told, was 4, the maximum was 5, and I know that right in between, the very half is 4.5. So I know that that's going to be my halfway point. I also need to know the distance between the halfway point and my other values. And I know that since this is the middle, it's going to be the same, and I know that this is 0.5. So with all of this information that I found, I can now write my equation. So I know I'm going to have my absolute value symbols equals. So the absolute value symbols are going to equal the difference, the distance here to the halfway point. So this is going to go on this side. I know I'm going to have x and minus, and here's where I put the midpoint, so my 4.5. So now I can go through and double check the answer, right? And I plug in both things. So I've got 4 minus 4.5, but again, my absolute value equals 0.5, and then I have 5 minus 4.5 equals 0.5. And all I did here was I took our two starting values and I plugged them into the equation that I came up with just to double check. So let's go ahead and look and just double check that our math was correct. I know that 4 minus 4.5 is 0.5. Negative 0.5, because the 4.5 was bigger, equals 0.5. This is true, because remember, one of our properties is if I have a negative absolute value of something, it makes it a positive value, so those two things are equal. And I know that 5 minus 4.5 is 0.5. And the absolute value of that is the same thing as 0.5. So those are both correct. So we know that our equation, which is right here, was right. So now here's some examples that you can just try on your own to see if you're able to continue with these examples. So here's another core concept, solving equations with two absolute values. So see, we have one on this side and one on this side. And so we have to be able to look at these two things. So here's how I do this. I write my first equation just the same way I did, without the absolute value symbols. Then I have to write my second equation as I take the first one just fine, and I make the second one completely negative. Here's the thing is, don't forget your parentheses on that second one to distribute the negative sign. So here's our example. We're going to look at part B to solve together, just because it's a little more difficult. So I know from the previous slide I have my 4x plus 10 equals 2 times the absolute value. So I'm getting rid of the absolute value right now. I'm turning this into some parentheses. 3x plus 1. That's my first equation. Then my second equation, right, the first absolute value stayed the same, so 4x minus 10 equals, then I had to make everything on this side negative. Negative 2 times 3x plus 1. Now I can just solve both of these equations. Okay, so now that we're here, we can go ahead and distribute and solve. So I'm going to have 4x plus 10, and I don't know where this plus came from. I was incorrect on that. It is a subtraction. So we're just going to go back and double check and change that. So that's gone. That's a minus. 4x minus 10 equals 2 times 3x is 6x. 2 times 1 is 2. Then I know that I have two different values with x's and two different values without x's. So I'm going to subtract 6x from both sides to move all of my x terms over to one side. So I end up with a negative 2x, because 4x minus 6x is a negative 2x, minus 10 equals 2. So now I have to get all my constant terms to the other side, so I add 10 to both sides. So now I'm left with negative 2x equals 12. Then the next thing I do to get my x value by itself is, since I'm multiplying, I go ahead and divide by a negative 2. So x, I know, is a negative 6. That's one of my possible solutions. So the other solution, I have to look at this and do the same steps. So I've got my 4x minus 10 equals, this negative 2 times 3x is a negative 6x, negative 2 times 1 is negative 2. So I'm going to follow the same steps. I'm going to move my x values, but here I add, because over in my original problem it's subtraction. So I add 6x, so I have 10x minus 10 equals negative 2. Then I add 10 to get all my constants on one side. So 10x equals negative 2 plus 10 is 8. And then I divide by 10. So I have x equals 8/10. But I look at that and I say, that's a fraction that I know can be simplified. And I know that I can divide both the numerator and the denominator by 2. So I'm going to go ahead and simplify my fraction. So x equals 4/5. Then I'll make sure I want to go back and double check my work to make sure that I was correct. So here's a couple that you can try on your own. So example 5. Here we are looking for extraneous solutions. Now an extraneous solution we solve and we get that it is a solution, but then when we go back and double check, we realize that it doesn't actually work. So let's try this one. So I see I'm solving 2x plus 12 equals 4x. And I know that my first equation, 2x plus 12 equals 4x. I write it just the way it's written up in the original equation. And my second equation is going to be 2x plus 12 equals a negative 4x. So I just make a negative the other side. So then I know I want to get all of my x values over to the right side. So I subtract 2x. And I subtract 2x. So I'm left with 12 equals 4 minus 2 is 2. Then I can divide by 2. And I divide by 2. So I get that 6 equals x. And we'll come back and double check that in just a minute. So I want to follow those same steps over here. Negative 2x. So I subtract 2x. So I'm left with 12 equals a negative 6x. Again, I divide by whatever's with my x by this negative 6. So then I have a negative 2 equals x. So now I'm going to go back and double check the work. So I take the value that I'm given and put it back into my equation. So I would have the absolute value of 2 times 6 plus 12 equals 4 times 6. And I can double check. So 2 times 6 is 12. So now I have the absolute value of 12 plus 12 equals 4 times 6 is 24. So I can just see this, that I have the absolute value, 12 plus 12 is 24, equals 24. This one works out. This one is a check mark. That one is true. So let's try this one back up in my original equation. So I've got 2 times a negative 2, and the absolute value of that, plus 12. This 12 is also in my absolute value, equals 4 times this negative 2. So I see that over here I'm going to end up with a negative 8. Now remember back at my original when I started, one of my properties, I can never have an absolute value of something equal a negative number, so I know that this one does not work. So take just a minute now and look back at your learning targets to see how you did for this section.